Good morning, everybody, and welcome to the WaterWarmth webinar. This webinar is on evaluating the potential of aquathermal energy systems and the WaterWarmth Quickscan tool. I'm your moderator for today's webinar. My name is Martina Battocchio. I'm a EU Projects Officer at the European Heat Pump Association, one of the partners of this Interreg North Sea project. Just walking you quickly through our webinar agenda. So now it's time for the introduction done by me. And then we'll move on to the first presentation of the day, which is aquathermal energy and the WaterWarmth project, done by our first speaker, Len Kousman, project engineer at ExtraQT. Then we will move on to the Quickscan presentation done by Michiel Fremou, researcher at Delft University of Technology. And he will also give us a short presentation on the next steps in the project. And finally, we will close the webinar with our Q&A session. So without further ado, I will quickly leave the floor to Len, who is he is an industrial chemical engineer with a postgraduate in innovative entrepreneurship for engineers. He applies his practical and organizational expertise as a project engineer at ExtraQT. And since 2024, he has been dedicated to advancing sustainability through aquathermal energy. So I will now leave the floor to you, Len.
Yes. Good morning, everyone, and thank you for the introduction, Martina. All right. So I prepared a short introduction where I first go into what aquathermal energy is, what the potential might be in Europe, and then why we are here, what the WaterWarmth project is, and then Michiel will continue with more details about the Quickscan. So aquathermal energy is short said as a source for heat pumps where we use surface water. We extract heat from surface water, which we send to the heat pump, and the heat pump supplies heat at the right temperature to the building. If you look at surface water or a water body, it's often portrayed as something without any interaction with the environment. It's just some water. When you start taking heat out of it, the temperature will diminish. But what actually happens is that there is a lot of renewing effects of temperature in the water body. And that's what makes it an interesting energy source, because the environment, the sun, everything else charges your water body and provides energy for the long run. There are different technologies to extract heat from these water bodies. It can be with an open system or with a closed system, but I won't go too much into detail. The principle is that just like with an air source heat pump that takes heat from the air, or with a ground source heat pump that takes heat from the ground, here the heat pump takes heat from surface water. And we have been studying the potential of this technology in the North Sea region. This is a very recent thing we've studied, and what you see on this slide is actually what fraction of heat demand is is being able to be supplied by aquathermal energy. And for some regions in the North Sea region, there's a quite big potential compared to the demand. And in a lot of others, there is also quite a substantial amount of heat that is able to be delivered by aquathermal energy. So it is an interesting technology in the puzzle that we will need to lay together in order to reach sustainable heating by 2050. Now, what the WaterWarmth project does is, it's an Interreg project and North Sea project that aims to accelerate the transition towards sustainable heating and cooling. And we use this surface water as energy source. WaterWarmth consists of a few work packages. So the first one, we want to show the potential of aquathermal heat systems. There are also 2 work packages about pilot sites. We will build 4 to 6 small-scale pilot sites, and we will also develop a methodology for 3 to 4 large-scale pilot sites, and if possible, also develop them and build aquathermal installations for those large-scale pilots. We work on system integration of the aquathermal energy into the broader network of energy. We also work on determining the market potential, and we will improve the insights in governance of collective energy systems based on aquathermal heating. The project partners, we are with 18, spread in 6 countries. I will not go into detail. And also the pilot projects are spread in these 6 countries. So this was a short introduction into aquathermal energy and the WaterWarmth project. And Michiel can now go into detail of one of the things we developed in work package 1.
Sorry, I just noticed my microphone was muted. Hello, everyone. My name is Michiel Vreemal. I'm from TU Delft, and I will tell you something about the Quickscan that we have developed. What you see here now is the title screen. That also gives you an idea of what it's about. And the idea is that the tool will be able to tell you if your building or your project is a match for a nearby surface water body. And it's intended for anyone who's interested in aquathermal energy as a heating source for their buildings. You do not have to be an expert. This is very important. So, oh, I'm going a little bit too fast. It will help you do a first assessment. So there are steps to follow. This is a very quick way of determining if it's a feasible option for you. It's revolved around 4 categories. There is the start, of course, where you will tell which country you're from. There are some local values that the tool uses that it will then select. If you don't fill out anything, it will use an average one, so that's also not a problem. Then you have the 4 categories. And each of these demand, water body, infrastructure, and restrictions and permits asks a couple of questions, somewhere between 4 and 10. Some require you to fill out a number, for example, heat demand. Others are more qualitative. So, for example, is the insulation in your buildings high, medium, or low? It's intended as a low-level tool, so we want to make it as easy as possible for you to get an idea of where you stand. It gives an output in the form of a traffic light. There is a red light. That means that you have answered one question where that's a serious issue. We call them deal breakers. There's very few of these. In most cases, it means that you will get a yellow light if something is not as expected, and then that's just more of a attention to fix this. And if most of it is okay, then you get a green light. This is for each of the separate categories. There's also the result overview, where you can see how you score on the different categories. But these are the general results. We also encourage you to look at the categories themselves. Each tab has a feedback sheet at the bottom that tells you where it is and what's good, what needs addressing, and what could possibly be a deal breaker. This is one example of how the tool works. You start with the water body type. It goes a little bit faster than intended. It's skipping things there. So the water body type itself is divided in 3 options: still, flowing, or coastal. Flowing can be a canal or a river with a flow, and coastal is, of course, anything at the coast. That determines which calculation is used. We ask questions. The tool has answer thresholds, and then it determines what your score is based on that. Some questions will be asked for all categories. Some are specific to one of them, and they will also be grayed out if you don't need to fill them out. So then you can just ignore them. Then for the water body type, skipping all of the animations for some reason. So this is again the start. You fill this out, and you only have to do it once. It's just the second slide, and then it chooses a means of calculating the potential. This is based on different thermal dissipation types. For still water, the surface. So then we look at that. For flowing water, and you can forget this this formula, but it's about cubic meters that flow through your water body at a certain temperature, and you create a difference. That's your potential. And for the coastal calculation, it's not quantitative. That means you can pump in and out as much water as you can, depending, of course, which permit you get. It's mostly about what delta T you can achieve and how cold the coastal water gets. Then you get an output. It's a potential heat supply. It's a simple calculation, so please do not start any business plans after you filled out the Quickscan for 15 minutes. But it gives you an idea of the order of magnitude, if it's a match to the demand that you filled out or not. So then we go to the live demo. Here is an example. I'll just go back to the start. This is the screen you just saw. This is the main start. We can specify a location. I'm just going to do Belgium again, and it will explain a few things about what the tool does. Also, what it doesn't do. It's under construction, as in we have released version 1. But if you see anything that you think could be improved, or if you find any bugs, please let us know. At the end, there is a link to the feedback form. So please let us know. Going back here, you can also always find the latest version here and here as well. Then going to the first slide, the first tab, heat demand. You have 2 options. If you already know exactly what your heat demand is, you can just fill something out. You can also estimate if you're not sure. You can also choose the units, by the way. So if you have cubic meters of gas, that's no problem, or any of the others, the tool internally will convert this to what it needs. You can also fill out square meters based on what type of building it is and how old it is. These are very rough estimates, so if you know it, this is better. If you fill out both, the tool will choose this one. So if you want to estimate, just delete it. You can also see this change to estimated, and then you get this. And then you can fill out some things. There's pull-down menus in this case, and here as well. And you get some information on what the question is and how you can fill it out. And here are any suggestions or feedback based on your answers. At the base, at the bottom, this is also summed up. So the things that are great, that are working out, the things that need some attention. And if there's anything that is a serious issue, it will be listed here. There's none right now because I filled out a couple of things like this. Say I know exactly how much space there is in the technical room, then it switches to green. Just means there's few issues, few to none. The second tab is the water body. That's the one I just talked about. So here you fill out. You can see also that the answers change based on what I fill out here. I'm going to say yes, it has a flow, and no, it's not a coastal water. So then it knows what calculation type it needs. And you can fill out the various values here as well. Again, pull down menus in some cases, places where you fill out numbers in others. You can also change units in some cases, centimeters if you want, cubic meters per second or cubic meters per hour. And the rest is hopefully self-explanatory. Again, there is a category score and there's feedback. Third tab, same thing. I'll not go into it too much because I think you understand the mechanism here. And then the fourth one, which is about restrictions and permits. These most likely will always be a yes because, well, you can't indefinitely discharge water of any temperature into public waters, but in case you do, you can switch it. Protection, also yes or no. This is a strange one, but you need to know where you have to request the permit, and these can differ. In the Netherlands, there's two categories. There is the Rijkswaterstaat, which is the national body, and there is the water boards themselves, of which there are like 36. So you have to know which one you need to knock on their door and talk to them as well. Other permits, is there a charge? This is specifically Flemish one, I think. That might influence the business case. So if you say yes, then you get a different score. And again, here's the feedback. I'll show you one deal breaker actually. If your heating system is very high temperature, old-fashioned radiators, that would be difficult for an aquathermal energy system. It's not impossible, but it will not be as efficient and therefore quite expensive. So then you get a red one. And then after you've done these four, you can go to the result overview. This is your general result. So you can see most cases it's okay. And here there are some things that need addressing. Doesn't mean there's zero issues, just that we're not expecting anything to be problematic. And an estimate of how demand and supply match up. Then finally, I have pointed this out at the start. We have a feedback form. So if you see anything that you think could be changed or improved, or especially when it comes to the feedback that the tool gives, the background information in order to fill out questions, we are very happy to hear all of your feedback. We have 6 countries and with some languages that I do not speak. So I'm very happy to hear if there's anything that we can add that will help you fill out the tool. Just to finalize, what you just saw was the Quickscan that gives you the quick indication of if it's an interesting thing. Following this are pre-feasibility and feasibility studies, which Len will tell you a little bit about.
All right, so the Quickscan is part of a certain flow, which will eventually end up with a feasible or non-feasible project. So the Quickscan is actually the first gives you a first idea if aquathermal energy is actually useful or not for your project. If, as Michiel showed, there are no deal breakers in the Quickscan, or there are not a lot of orange lights and a lot of green lights, then you know that it actually is a valuable or a possible technology for your project. And then you can follow up the Quickscan with a pre-feasibility study and a feasibility study. What the pre-feasibility study does answer some relevant questions. For instance, what are red lights that would make the project not feasible? And it goes more into detail than a quick scan, because in a pre-feasibility you have, for instance, a site visit that will see if the water body is actually reachable by your project or not. It also tells you what needs to be studied in detail to make sure that the project becomes feasible. It asks the question what the first impressions of the public water authorities are, because that's a very important step, that you have confirmation from the public water authorities that you can use their water body as a heat source. And mainly the pre-feasibility functions as a step before an expensive or elaborate feasibility study to just say, does it make sense to order a full feasibility study? Even the pre-feasibility study, there are no big red lights, let's say. You can go to the next step, which is the feasibility study, and that's actually a detailed analysis of the project. And it has 4 main subjects. First one is the thermal impact on the water body, which is for most regulations something you need to know. There are, in most countries, there is a limit on the thermal impact you can make on the water body, so it needs to be studied in detail for your project. The feasibility study also concerns a technical concept development, and as third, a more elaborate, let's say, talks with the public water authorities, and the aim is to get a pre-agreement for the project. Not a full permit, but the agreement from the authorities that there is some music into this project. And the fourth question that is answered in the feasibility study, which is for most parties the most interesting one, is how does this project look financially? Is it compared to alternative scenarios? Is it a good idea to use aquathermal energy? It's also worth mentioning, I think, that we will have a separate webinar on these 2 things, the pre-feasibility and the feasibility study, where we go more into detail what are the different parts of the pre-feasibility study and the feasibility study, and how you can achieve the right answers on these questions. But that is something that will come in the future and will be disseminated through the same channel as probably where you've seen the invitation to this webinar. Right. I think we can go to the questions now. If you haven't already, you can post the questions in the chat and we will take them up.
Yeah, so we currently have 4 questions in the chat and 1 in the Q&A section. So we'll start in the chat. Sofia Silva says, hello, thank you both for your presentations. I have one question. What is the potential of this technology in Southern Europe? Is it the same as that presented for Northern Europe? I think it's both. It's to both of you.
I think I can answer this. So the potential analysis we have done looks for heat demand and also the potential of the water bodies around heat demand. So it's actually not easy to answer, because it's a very, let's say, low-level analysis, very local level analysis. But what I can say is if there is water around, then there is a high chance of it being able to be used to heat buildings. Of course, the more you go to the south, the smaller the heat demand becomes and the bigger the cooling demand becomes. But we see aquathermal energy more as a heat source than as a cooling source. But it would mean that if you go more to the south, the potential will increase. You will be able to heat more houses than you can in the north, providing there is enough water available. I hope that answers your question, Sophia.
Thank you, Len. Then we have 2 questions from Luis Miguel Blaines Restoy. He asks, is the tool available for testing with other case studies or to develop a case study as a master's student dissertation or final year project?
It's there for download, so yes, you can use it. If you want to grab it and have a look, I think the download link is, did we post that already? I'll put it in chat so you can have a look.
Okay, thank you, Michael. Next question is from Gerk Jan Kuipers. He says, thanks for the presentation. Sorry,
He's a colleague.
not a question,
He's
he's just leaving.
That
was super nice. Thank you for letting us know. Then moving on to the Q&A section. Andy Frew asks, could your tool estimate if sources are suitable for intermittent extraction of heat for storage? For example, using intermittent wind energy to produce heat for use weeks later.
I think that's a simulation question. That's not what the tool does, no. This is meant to, if you know already what your project is about, to fill it out in maybe half an hour and get a first look of all of the intricacies of aquathermal energy, because it's an environmental thing. There's a lot of other questions, as you've seen from the categories. What you're talking about is doing a full-blown annual simulation of different sources. I think we have something like that under development in WaterWarmth, in work package 4, but that's a different tool. We will probably do a webinar about that later.
All right. I don't see any other questions, but you're free to just pop them in the chat. I have 2 questions for you, Michiel. So concerning the Quickscan tool, you said during your presentation that is currently in development, so it's not yet set in stone, let's say. So what new modifications do you plan for it? What are the next steps?
Well, one is just if we have more specific data for the different regions. The North Sea region is that strange shape that you saw on the map that Len showed. And we have, of course, focused on those places where we have partners. But in some cases, the data is a bit more difficult to dig up. So if there's any question that you think is difficult to answer, but you also happen to have a data source, then we are very interested in hearing from you. So that is one, making it even easier to answer questions. That applies to the descriptions in the questions as well. And I think we might add some more intricacies. I'm not sure which ones yet. That's something we have to discuss. We just released this one. But there will be further development till the end of the project, which is, well, actually it's December, but in June will be the deadline for this tool. And anything that you think, go ahead.
I think it's important to notice that this tool, as it is now, is already very useful to use to get a sense of the if aquathermal energy is a good idea for your project or not. We will develop it further so it has some more functionalities, but it's already a very good Quickscan tool as it is now.
And regarding suggestions, please make any, but we do have to keep in mind that it is a quick scan tool, emphasis on quick. So if we add too many questions, then of course that will not be a quick scan tool anymore. But again, we're happy to hear your suggestions. Thank you.
Thank you, Michiel and Len, for your reply. Luis Miguel asks 2 questions. So the first one is, would you let us know what is the plan for dissemination of the tool? We would be interested in being tester, follower, user. And the other one is, he says, I believe the biggest barrier is regulatory and preemptive conservationism geared position of regulatory bodies. If we can demonstrate that the temperature of the water will not vary substantially, it would be easier to be seen as good source of heat pump heating. Is there any case study in the project that is looking at these effects?
I would say so, yes. One of them is actually the pilot that I run myself. It's in Delft. It's using a standing water, which is not happening very often. That's the most limited of all of the renewable potentials of aquathermal energy. And Len and his colleagues have done simulations that say that even in this very small water, the maximum temperature drop of heat extraction in winter will be 0.71 degrees. So we would say there's a lot of potential. We have gotten the green light for making the investment. So we will be building a pilot that does this, and we're going to be measuring it over the next 1.5 years. And then we have data that, well, hopefully shows that this is all totally okay. Len?
I can elaborate on this. Well, one of the specialties of our company, Extract, is to do simulations on the impact of a certain heat demand on the water body. And we see that in a lot of cases, there is actually plenty of potential, and the impact on the water body is quite low, especially with flowing water bodies, canals, rivers. Actually, you have quite some potential to extract heat from that water body without decreasing the temperature in the water body with any meaningful amount. And also, this is well, in the slide I showed with the potentials in the North Sea region, we've already taken that into account. So actually, we apply a maximum difference in temperature of, I think, 3 degrees to the water body, and then we calculate what amount of heat we can get out of the water body. So we've taken that into account, yeah.
All right, thank you both for your questions. Yeah, Luis Miguel says brilliant, so replies appreciated. If there are no other questions, I don't see anything new on the Q&A section or in the chat. So I think we can officially close the webinar. And
being raised.
Yeah, but maybe there was a mistake. Glitch. It happens all of the times to me as well. So thank you everybody for attending this webinar. You will receive a follow-up email with the presentation that was shared today, and with
and a link to the Quickscan tool.
Yeah, exactly.
Also in chat, but yes, it will be the email too.
And also the recording, but don't forget to follow us to know more, and social media pages of the project as well. We will have another webinar organized on the 25th of November, still on this project. So please, if you haven't yet you can register for that webinar as well to know more. And yeah, I wish you all a pleasant day and rest of the week. Thank you for attending.